If we had that, what can I do with it?
Yep, you can do lnx.
Yeah, but I'm not wanting to simplify it, I want to change into another form. So when you got it written in log form, what's the other form you write it in?
Exponential form.
Exponential form. So what do I do to get an exponential form?
X equals log.
I squish out the e, I squish out the e all the time, and I've got x equals e to the y. So that's x equals e to the y. But instead of squishing that way, I'm squishing this way. Does your brain think about the log is the y? No, that's why I talk about the squish method all the time. So what have I got now? X equals e to the y. Can I differentiate that? You bet I can. What's the derivative of e? Stays the same. You're okay. I don't want dx dy though, what do I want? And if it was fractions, I'd say if I turn this fraction upside down, I turn that fraction upside down, it's e to the y. So, what's the derivative of, I started with y equals the log of x, and I ended up with 1 on that. But what can I write instead of e to the y?
Log e to the base of y.
X is e to the y, so instead of e to the y I can write x. So the derivative is 1 on x. Now let's do some questions. So what if I had log of 10 log of x base e? I know the derivative of that is what?
1 on x.
1 on x.
10 on x.
10 on x. Do another one. What if I had 5 ln x? And I want to differentiate it.
It'd be 5 on x.
5 on x. So what's going to happen when I have the ln of 5x instead?
Change 1 of 5x.
Be fussy for a moment, I'm going to put the brackets in. Where did the x go to? To the bottom. So the 5x goes to the bottom. And what do we have to multiply by?
Whatever that from.
Wait, no.
By, yeah, say from
5.
by 5,
5.
which is the derivative of the
Inside.
But then
inside.
wouldn't you just get
Yeah, wouldn't it just be 1 on x?
Yeah. So one of the annoying thing about the logs is the log of 5x and the log of x are the same thing, 1 on x.
Isn't that
So then we're going to go a step further. So if we
shouldn't
come
that
over
be
here,
anything?
let's make it less. Now let's go to something that sort of does something with it. Let's go 3x squared plus 1. That'll do. Y dashes. What do you do with it? The function that's on the inside goes to the
3x
denominator.
squared plus 1, and then on top is 6x.
No. Oh, yeah, that's one.
Done.
You can take
When
out
we go
6
further,
and-
make up another one. The ln of something stupid like, I don't know, let's go 3 root x minus 5.
Put it on the bottom,
Put on the bottom.
and times the root.
Yeah, the derivative inside is Bit annoying.
3 on, negative 3 on 2 root x.
negative 3. So let's do it slowly just in case. So what have we got?
Negative
3x to
2
the half. So if I was differentiating that, what is that?
Oh,
3 onto x to the
negative.
negative half. There's a numerator, there's a denominator.
So it's gonna be
This becomes a denominator with a square root. So it's got a 3 on the top, it's got a 2 on the bottom, and they, say it for me,
root x.
root x on the
So
bottom.
it's not negative.
So it's 3, no negative. 3 on 2 root x on that. Revolting.
What can you make? Can't you just like times the 2?
Yeah. So we can go to, equals off times 1. What else can I do? Get rid of fractions. How can I get rid of fractions? By going times by 1. How can I times that by 1? Times it by root x on root x. Is that of an advantage? Maybe.
Shouldn't we do 2 root x instead?
By the way, at that point the question's done, isn't it? The rest is what?
History.
Rearranging. So what's stupid is we've gone to feral stage on a simple concept, and all I showed you was the upside down of,
Yeah.
instead of doing y equals e to the x, we did x equals e to the y.